Get a fairly good clip. All right? Everybody good? Everybody got the notes? Okay. We are going to work, this unit is graphing. I only need literally 2 days, maybe 3 tops to do this. And then I got to cram your last unit into like 2 days. But we'll see what we can do with that. We will begin with graphing things first. An X-Intercept. Before I go on, I need to remind you of the following. From last unit, X, Y. That line goes through, it hits the Y-axis, and it hits the X-axis. Yes? That is an X-intercept because it crosses the X line there. You already know that. That is a Y-intercept. Here is the thing that nobody thinks about when I say that. The coordinates of this point, coordinates on the Cartesian plane have 2 parts, yes? An X and a Y. Do you know that X value? No. Do you know that Y value? What's the Y value, Navneet? 0. This X-intercept is X, because you don't know what X it is, but it's always 0Y. What then is a Y-intercept? 0 for X, and what value for Y? Y, because you don't know. Does everybody understand that? That concept is absolutely key to this whole unit, and people have trouble with it. Is everybody okay with that? It's grade 9, right? X comma Y. We know how to do it. All right. So an X-intercept is where any, please underline any because it doesn't have to be a straight line. It can be curvy. Where any graphed line crosses the X-axis. And they are all X, comma, 0. Always. Doesn't matter where. It's going to be some value of X, but it's always going to be 0Y. Got it? Now, you guys are smart kids. Y-intercept, where any blah, 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 blah crosses the Y-axis. And what are its values? 0, because it's always going to be 0x, and some value of Y. Is everybody good? Is everyone okay? It's easy, right? Now, the next concept that people don't understand is this concept. 3x plus 7y equals 10. What do you see there? An X. What do you see there? An X. What do you see there?
0.
But that 0 represents what? X. So, all of these things can go in there. Do you understand? What if I gave you this? What's that? That's an X, isn't it? What's that?
Y.
That's a Y, isn't it? So what can I do with that X and Y? Put them in to an equation. That concept, for some reason, is very confuzzling to people. Is it confuzzling to any of you? I hope not. Every X and Y can go in anywhere you see an X and a Y. Just like you learned in grade 9. Everybody good? Okay. Now, I didn't notice this, of course, until I pushed print and printed 25 copies, that a lot of your guys' work, eventually it's going to start shifting downwards, and you're going to lose pieces of work that are on mine. I apologize, I'm sorry. I don't want to print another 25-page book 30 times. When it happens, we'll sort it out. Okay, but this, you should have room on your first page right now. this should be there. Is everybody cool? All right, now, this reminds us of last term. Here is the equation I have. Please notice there is no y, is there? What in function notation has taken the place of y? The f of x, right? So this y axis is also our output axis. Everybody cool? X is still x. So now I want the x and y intercepts of that function. We know what every x-intercept is, don't we? What is every x-intercept? x0, correct? What is every y-intercept? 0y. That's an x, that's a y. What's that? X, what's that? So what can I do? What do I get to do with this x and y? Remember, this is really y equals 2x plus 3, yes? Well, here I have an x and a y, don't I? So what do I get to do with them? Do I know the value of x?
No.
I need to find it, don't I? How will I find it? By doing what? Putting it into the equation. So fill it in. So the x-intercept, which I will be writing in black, y is what? 0 equals 2x plus 3. Everyone agree? How will I get x? Because I need to find x. So I got to do math to get x by itself. What do I got to do? Pardon? Algebra. What do I got to do to get that x by itself? Subtract 3. I'm just going to move it over. And what does that become? Negative 3 equals 2x. Now what? Divide by 2. And what does x equal? Negative 3 halves. Now, that same concept comes back to use again. X is now negative 3 over 2. Do you see an unknown x somewhere in this question? Right there, yes? So what is our x-intercept? Negative 3 over 2, 0. Is everybody good? I could put that on the graph now, yes? Why do you think would I not want to put that on the graph right now? What about that is weird? It's a fraction. I don't want to put that on the graph in case my y also has fractions. Because if my y is in quarters or eighths, it's real easy, isn't it? But if my y is in thirds, that's a mess, right? So we're going to check our y first. And I'm going to do that in red. Now I have 0y. That 0 is what letter? X. There's an x, right? So now I have y equals 2 times x plus 3. 2 times 0 is what? 0. So y equals 3. Everybody's good, right? What's our y-intercept? 0, 3. Now I'm going to put them on the graph. Okay? Now, that fraction's a pain in the ass, right? What am I allowed to do to this scale to make it not a pain? Can I? If I make this 1, then that half becomes a real pain, doesn't it? But what if I make this 1? Now, what's this? 2. What's this spot right between it? 1.5. Now, I don't want positive 1.5. What do I want? Negative 1.5. So I go back 1, 2, 3 halves, and I put my dot. Does everybody understand? Now, y is 3. Can I keep the same scale? If I'm keeping the same scale, then it would be 1, 2, 3. It will fit on the graph, won't it? So I can keep the same scale. What if y was 8? Could I keep the same scale? No. Then what would I have to do to my y-axis? I would change it. I would make it 1, 2, 3, 4. You with me? Everybody's good? So I can put a dot at 0, 3. Now, is this a line that I'm going to draw? Is it a real life situation or is it just numbers? It's just numbers. So do I connect the dots? Yeah. Of course I do, because any number can be multiplied by 2 and add 3. So I make this line. Can everybody do that? Pretty easy, right? Now, very quickly, reminder from last unit, domain and range. That line's going to go how far? Forever. In which direction? Both, because it's going up and down, and it's also going side to side. So my domain, x, is all real numbers. Y is all real numbers. Is everybody good? Okay, believe it or not, that's half of this unit. Yes, that's how easy this unit is. If you understand x comma y, you understand this whole unit. So you guys do the next one. Remember, what is g of x really? Y. So I really have y equals 1/2 x minus 2. Why do you keep putting fractions in, Mr. Myers? Because does it matter what it looks like? No, because you follow the same rules. Now, x, 0, 0, y. You'll notice I did all that work without talking about it because there was nothing new there. I understand I was faster than you guys. That's okay. That's how it should be. But does everybody understand what we did? Do I need to go over any of this? Usually somebody asks about this part right here. How do you get rid of divided by 2? You got to multiply both sides by 2. So 2 times 2 is 4. 1/2 times 2 is 1x. Is everybody good? Can everybody find intercepts? You just got to remember, x 0, 0, y. Everybody cool? Does it matter how the equation is written? If I had both variables on one side, could you still do it? It would still be x would be x and y would be 0, and then x would be 0 and y would be y. Everybody's okay? All right. Okay, you guys have seen slope. When did we use slope? We didn't work much with it, but we talked about what it meant. What did it mean, for example, on a displacement time graph if it was really steep? Don't write this down. This is just a reminder. Displacement time. One minute. What does that mean?
Move the
I moved 100 meters in 1 minute, yes? That's not incredibly fast, right? Everybody good? Now, what would it mean if that slope changed to that? What has happened to my velocity after that? It has slowed down because I am covering less distance in the same amount of time. Everybody's good with that, right? So slope must deal with changes between our values, right? That's what slope is. So before we talk about slope-intercept form, we have to be reminded that slope is a measure of change. In which variable? 1, x, or y, or both? Both. Measure of change in both variables. All right? Everybody cool with that? This particular mathematical form, which you'll notice has y's and x still, this deals with slopes and y-intercepts. And we're going to come back to dealing with that in a minute, okay? These lines from science class you should already be able to explain. Here is where I start. Yeah? Here is where I end up. To get there, how can I get there? I'm not allowed to walk on the line. What is the other way I could get to that point? I can't do this. Oh, I left my leg. Now I'm going to be walking in circles. I'll give you a hint. That's a graphed line. What's the only way I can get up there exactly if I'm not allowed to walk there diagonally? I got to go over and up, don't I? Everybody agree? I could go up and then over. Or if I was up here, I could go down and that way. Now, there's a reason I said up first or down first. Does anybody want to guess why?
Rise over run.
Everybody knows it's rise over run, but why is it rise over run? Why is it delta y over delta x? Can x change without y in reality? Time can't go on without y changing. Everybody understands that, right? That's why it has to be rise over run. Because you have to have a change in your y value. Okay? So you all know this from science already. This is rise over run, right? So we count our delta y. Delta means change if you haven't done science yet. And delta x. Now, if I give a speed, how do we write a speed? Kilometers per hour, yes? Right? Kilometers would be on the y value, wouldn't it? Hours or time, they'd be on the x value, wouldn't it? So it's kilometers divided by hours. Right? If you're doing typing class back in Infotech 7 and you did Typing Tutor or Mavis Beacon or some stupid program like that, it gave you a words per minute, didn't it? Mm-hmm. Words up here per minute. Words divided by minute. Everybody get it? Now, when I go up on a graph, is that positive or negative?
Positive.
Positive. When I go right on a graph, is that positive or negative?
Positive.
Positive. When I go down, what is it?
Negative.
Negative. When I go left, what is it?
Negative.
So if I'm dividing, positive divided by positive, what do I get?
Positive.
Positive. Negative divided by negative, what do I get? Positive. So this is a positive slope. Now remind me again how many of you have not done science yet? Not done it this year. Okay, so for everybody whose hand is up right now, this might feel like it's going a little bit fast. But for everybody whose hand was down, you're all like, ugh, I know this already. Okay? So I'm going to try and be in the middle speeds. Okay? So you guys are smart kids. If this one is positive, positive, or negative, negative, what's this one?
Negative.
I can go up, that's positive, but then where would I have to go?
Negative.
Negative. Or I can go down, which is negative, and then that way, which is positive, right? So if my line leans this way, it's what we call a negative slope. And that makes sense in our displacement graph, doesn't it? Because when we're going away from home, we're getting further away, positive distance. When I flip it around and turn back towards home, I have a negative slope, so I'm getting a negative distance, negative displacement. Everybody good? Now, what's weird about this one?
Straight line.
Straight line. So, what is my rise? If I go up, it's what? If I go down this way, it's negative, right? But what's my run?
0.
0. So, can I divide by 0? No. This is what we call undefined. Because if you try to divide by 0, you can't do it. It's infinity. This is not a slope. If I said to you, hey, let's go ski down that undefined slope, would you be skiing?
No.
No, you'd be falling. Understand? It wouldn't be very good. Here we are. Woo! What's going to happen?
Splat.
Ah! Oh, I left my snowboard up there. Not that I snowboard. I do sometimes. Depends on who I'm going with. Now, what's this one?
Straight line.
It's also a straight line. Would it be fun to ski?
No.
Why? Because it's got 0 slope. Why does it have 0 slope? Because I have 0 rise over a run. If I have no pizza, can I divide it?
No.
No, still got no pizza. So that's why this is a 0 slope. And I'm sure I wrote 0 slope and it disappeared.
Yeah.
Okay. I'm David Blaine today. It's disappearing everywhere, all over on me. Everybody good? So now, half of you already knew that slope was rise over run. Now all of you know that slope is rise over run. So slope, it's also in this unit and in all of math, the letter M. I don't know why, don't ask. So M is slope. It's also rise over run. It's also delta y over delta x. It's also delta dependent variable divided by delta independent variable. Is everybody good with slope? Now you guys aren't stupid. If I give you this, 3, 2, what's that? X and y. So it can go where in an equation? Everywhere you see an X or a Y, right? If you know a rise over run, a delta Y over delta X, or a delta dV over delta IV, where can you put it in an equation? Anywhere you see M. Cool? Everybody's okay with that? All right. So let's turn the page over, and you guys should be able to do this. Graph each of these using slope-intercept form. Well, slope-intercept form, I'll remind you again, is y equals mx plus b, right? M is a rise over run, and b is a y-intercept. So if I want to graph these 4 lines, where should I start? With my slope or with my y-intercept? With my y-intercept, because I need to know from where I am counting my rise and run, yes? So, looking at A, This looks a lot like this, doesn't it? There's an x, it's got a coefficient, and it's got a constant. That constant is my y-intercept, correct? So where do I go to put my first dot on this graph? -4 on the y-axis. I'm using red, so I'm going to do A in red. Now, I need a slope of 2. Slope is always rise over run, correct? What is the denominator here that should be my run? 1. So I need to rise 2, 1, 2, and I need to run 1. Now, is it enough to put on only 2 dots? No, you've got to do 3, because this down here might be over here or way over here. So I got to go down 1, 2, and left 1. And then I can make my line. That's a horrible line. Shush. I'm 40 years old and I have no iron. I'm a little shaky. There. That's not bad. Everybody cool? Somebody said something mean to me, but I'm okay. I can handle it. Happiness is a state of mind. You guys do me. Oh. What's funny is you think that I don't know what she said. That's what's funny. I know exactly what she said. She should probably bring her mind out of the gutter. It's the same joke I would have made if I was teaching grown-ups, not kids. Let's do a blue one for B. What's my y-intercept? 1. So where do I go? To 1. What's my slope? -1. So I go down 1 to get my negative rise, and then where do I have to go to keep the slope negative? To the right 1. Is 2 dots enough? No, I got to do 3, so I'm going to go up 1 and left 1. And then I'm going to make that line. Everybody cool with that? Okay, I'm going to use black to do C. What's my y-intercept? 5, so where do I go? Up to 5, on which axis? The y. 1, 2, 3, 4, 5, and I put a dot. What's my slope? -1 over 3. So if I go down 1, what direction do I go to keep this slope negative? Right, 1, 2, 3, or up 1 and left, 1, 2, 3. And then I make that line. Everybody cool? And finally, I will do this one in green. D. What's my y-intercept? It's a tough one. What is it? 0. There is no y-intercept there. Do we have a number that represents 0? Or do we have a number that represents nothing? 0. And what's my slope? No. 1. Positive or negative? Positive. So up 1 over 1. Down 1, left 1. And I draw that line. Can everybody graph? Okay. Now, this says using the graph, find all of these. Why is using the graph a bad way to do it?
You have a different scale.
What if I've changed the scale? What if my lines aren't perfect? What if I've got shaky hands? Do we have a perfect way to do these? You just did a whole unit on it. Can we do these algebraically? Yeah. Do I need to? We just did this unit, right? F of x was 2x plus 4, wasn't it? 2x minus 4. Sorry, guys. I want the f of 2. So what do I get? 2 times what? 2 minus 4, which is what? 0. Can everybody still do this? Because I really want to skip this last little bit. You can all do this algebraically, right? Okay. This unit, it's more important that you can draw from looking at the equation. Everyone's good? I can skip? Yeah, awesome. What is another thing slope is? M. What's another thing slope is? Rise over run. What's another thing slope is? Delta y over delta x. What's another thing slope is? dv over delta iv, right? Could you guys draw all of those? Okay. E, I want you to put in this section. How are you going to draw a slope of 2/5? Who chooses where to start? You do. Doesn't matter. Put a dot somewhere on there and draw a slope of 2/5. There's my dot, up 2, and I run 5. That's what your line should look like. Everybody good? Okay. I want you to do F down in this section. There's the point I'm starting on. -4. Rise 4. Run 1. That's what that should look like. Please notice how much steeper it is. Is everybody good? G, I want to put over here. 0. It's got no rise. Right? And H, I've already done green. I need black. H is 7. What's my rise? And my run has to be -1 in this case because I dropped 7. And see how steep that is. Everybody good? Could I have gone up 7 and right 1? Yes. Could I have gone down 2 and left 5? Everybody's okay with that concept, because that's another thing that blows kids' minds for whatever reason. You recognize you can only fathom rise as going up, but it's also negative, right? Okay. Find the slope of these lines. So we're going to put 2 lines on this graph, yes? The first one, which I'm going to do in red, is right here. You guys already know how to do this. Put these lines on your graph. Do you guys still have this graph, or is it cut off? You have this one? It's tiny, right? So I'm going to zoom in on this, even though there's no real need to. You guys are more than capable of handling this. Where is -5, -3? Left 1, 2, 3, 4, 5, and down 1, 2, 3, correct? And 2, 1, 2, 1 is right there, yes? If I want that slope, I have to count rise over run, right? So if I start here, I go up 1, 2, 3, 4. Agreed? Everyone agree? +4. And then I go this way, how far? Everybody cool? So what's my slope here? Slope is rise over run. So it's 4 over 7. Everybody cool? If it's on a graph, slope is easy, yes? If you can count, can you find it? Yeah, done. So, let's look at this one. 0, -4. Right there. And 0, 3. Straight up and down. So what's my rise? 7. Negative 4 up to 3. And what's my run? 0. Is that allowed? Am I allowed to have 0 on the bottom of a fraction?
No.
No. So that's undefined. Can everybody count on a graph?
Yeah.
Okay. You guys are smart kids. Look at K. Did I give you room to graph it? Did I give you a graph? No. You don't have a graph here. Is there another way you can do this? What else is slope? It's delta y over delta x, yes? What does delta mean?
Change.
Change. Right? Right? Okay. What math tells you the difference between things?
Subtraction.
Subtraction. So isn't delta y one of the y values minus the other y value? I'm not allowed to write y minus y, am I? Because that gives me 0, right? So we write y2 minus y1 over, what do you think's at the bottom? x2 minus x1. Who chooses y2 and x2? You do. You choose. Here's what I do. I make this one y2 because it's the second one. If that's y2, what is this negative 6? x2. What is this 7? y1. And what is this 2? x1. And then I put this into this equation. 1 minus 7 over negative 6 minus 2. What's 1 minus 7? Negative 6. What's negative 6 minus 2? Negative 8. Two negatives make what? 6/8, and 6/8 becomes what? 3/4. So what's my rise? 3. What's my run?
4.
There's my slope without going to a graph. Can everybody do that? Now, you guys do that with L. y2 minus y1 over x2 minus x1. Remember, when I was learning this when I was your age, I labeled these every time so I couldn't screw it up. Because it's really impossible to do this wrong if you label it, isn't it? What do I put in for y2? The way I've labeled it. 15. Minus, what's y1? 4. Over, what's x2? Negative 5. Minus, what's x1? Negative 1. What's 15 minus 4?
No. No. I don't know where I got 9 from.
Nor do I. 11. Over, what's negative 5 minus minus 1? Negative 4. Because two negatives make a positive, right?
Yeah.
Is everybody good?
Yeah.
Okay. Can we skip number 3? It's on a graph, so what are you able to do? Count. Now, just take one quick look at A. Could you go from the ends of the line? Why not?
Then not touching points.
They're not exact, are they? You don't know. So what do you have to do with A to do it properly? You got to choose 2 points that you can do exactly. That's the only trick. Everybody cool? We can all count on a graph, yes? All right. And number 4. Draw a triangle where all the sides have a positive slope. Which way do positive slopes lean? They lean to the right. So I want a triangle where all the sides lean to the right. Can you do it? There's my Cartesian plane. Can you do it? How does it have to look? One of the slopes has to be what? Really low. Sam just did this. Really low. Right? Now I still got to keep it positive. So now where can I go? I could go really steep, couldn't I? Ah! Really steep. That's not quite leaned. Now what? Connect them with a slope that's in the middle. Everybody cool? The only point of that question is to let you remember that positives and negatives exist. Everybody good? All right, I'm shutting up. You will notice on your outline I've given you homework for these first 2 lessons. You needn't worry about your textbook stuff. It's just more practice. So I'm going to ask you to do 5 on your own. Please skip to 6. We're going to do 6 together because 7, 8, and 9 require you to be able to do 6. So please go to 6. 7, 8, 9. So, what do I have there? What's this? An X. What's this? A Y. What's this? Another X. So X2. What's this? Y2. I know that the slope is 2. Right? What else do I know about slope? Slope equals y2 minus y1 over x2 minus x1. Can you figure that out now? What is the slope? 2. I'm going to write it as 2 over 1, so I have rise over run. Cool? What's y2? Y. What's y1? 6. What's x2? -4. What's x1? 2. Do you guys know how to solve that to get y by itself? Of course you do. I'm not even going to do it. Everybody understand? How you solve that? Everybody knows how? What are you going to do with that algebraically? I would do something with the denominator on the right, personally. What would you do? Simplify. 2 over 1 equals y minus 6 over -6. Now what? You got fraction equals fraction. What can you do? Starts with a C. Ends with a Y. Has Ross multipla in the middle of it. Cross multiply. -12 will equal y minus 6. Now what? Did you say that? Oh. Oh, I see. What do you do with that 6? Move it over, so it becomes -6 equals y. Is everybody good? I know, right? It's not hard. It's algebra. It's grade 6 algebra, except now you've got a picture. Right? All right. Now, you guys, I want you to do 7, 8, and 9, and then see on, I believe it's page 9 for you guys, the sparkly assignment. That's homework. Okay?
Sparkly assignment.
The page that says assignment in sparkly font, which is actually called sparkly. Yeah. Is everybody good? Class goes for 20 minutes, I think, still. And I've only asked you to do 7 questions. Not even, 6. You can handle it. I will give you your tests back tomorrow when we have 80 minutes. Oh, these aren't hole punched. I know, right? Because the photocopier won't hole punch anymore.